go ahead and get started. So I am very happy to welcome Cindy Storey. She is a professor of computer science at the University of Victoria and a research chair in human social aspects of software development. She's also a fellow with the Society of Canada. Her research focuses on improving processes, tools, communications, and collaboration in software engineering for the purpose of improving productivity. And of course, her more recent work incorporates AI and how AI is supporting how research teams work, how they develop, share, and maintain their humanity complex software systems. I know that she can explain her work better than me, and so I'm going to hand the room over to her.
Yeah, thank you very much, Joe, for the invitation to come back here. It was actually quite a while ago that I was here before. I don't know if you remember, I was very pregnant. I'm very sick. The last time I was here, and I feel so much better today. Let me just tell you all that. So I'm going to be talking a little bit about some recent research that I have been doing lately. But I'm going to start off by just giving you a little bit of a flavor of some of the things that I have been doing over the past couple of decades. And also, just so you know, Peggy is short for Margaret-Anne. It's an Irish thing, I think, but just so there's no confusion there with what my name is. So as I mentioned, and as Joe mentioned, I've been studying human and collaborative aspects of software engineering for a long time, trying to understand how developers understand large software systems, how they work with others, how they work with the tools that they're using. And as you can see over time, okay, I have not been doing research since the 60s and the 70s, but certainly in the 90s, I started to see some tools shifting how developers were doing their work. I was developing myself at the time and saw things like SourceForge come along and new languages like Java and the IDE. And over the course of my career, as well as developing tools for software engineers, I've spent a lot of my time studying how new tools, how disruptive tools change how developers engineer their software and how they work with others. And of course, today we have AI, which is the latest disruption and having, I would say, causing a revolution in software engineering, which I'm sure anybody in the room feel that today. Yes, I see lots of heads nodding. So, but a few years ago, I shifted from just focusing on looking at tools and doing empirical work, and I tried to understand what is it that really makes a developer feel productive, and what is the connection with their perceived productivity by how happy or how satisfied they are in their work. And this was actually a multi-year project that I did in collaboration with Microsoft, and we did many, many different surveys to try to tease out what are the factors that lead to developers feeling like their work is that they are being productive in their work and that they are feeling happy. And what we found is that there is this bi-directional relationship. So developers that are happy are more productive, and developers that are productive are happier in their work. And along the way, we found lots of different factors that influence both of those. In particular, of course, engineering tools, feeling some autonomy, their skills, their work environment, had a strong relationship with their perceived productivity. But things like doing impactful work and feeling like an important contributor were also factors that influenced both of them quite strongly. And then, of course, for developer satisfaction, things like having work-life balance, work culture, and appreciation also had a strong impact on their satisfaction. But all of these factors influence both. And, you know, I was actually thinking about this a little bit this morning and thinking about the layoffs and thinking about what's happening in our industry. And all of a sudden I'm thinking these things are so important, feeling like your work has impact, feeling like you're an important contributor, your skills, feeling how you're feeling about this. All of these things are really bubbling up to be important right now. And then a few years after I did this study, I was supposed to go on sabbatical to Microsoft in Cambridge. And a couple of days before I was leaving, of course, COVID struck. And I'm sure all of you here remember this. Some of you probably are quite stressed thinking back on it. And so I changed my research from studying developers face to face to all of a sudden studying what happens when 43,000 developers overnight pivot to working from home. And so we did this study, and at first when we looked at their telemetry data, we saw something kind of surprising. It looked like the developers were actually being more productive. They were writing more code, they were reviewing more code, they were initiating more pull requests. And so when you look at the data, so the top line here was 2020, 2019 was the orange line, you saw that, oh, wow, things are actually going better. And this was a little bit surprising to a lot of people because a lot of the large companies were really forcing developers into shared spaces so that they would collaborate and talk to each other. And the idea was that they would be more productive. So what we did was, well, are they really being more productive or are just some numbers going up? Can we dig into this? So we did some interviews. We did a lot of surveys to try to understand what's really going on here when developers pivoted from working from home. And what we found is that actually there was this tale of two cities. I saw a tweet at the time by Shane O'Flynn where he said, we're doing very well, we're barely hanging in there. And we found that with the developers that were working from home as well. Some were absolutely thriving, and others, as you can see, on your right here, we're trying to juggle, childcare and trying to juggle work at the same time. And even though it looked like, looking at the telemetry data, that work was, that their productivity was going up, we started to see some cracks. We also started to see some cracks in terms of how they collaborate with others and how they network with others. So some developers were kind of sitting in their corner and not being interrupted. Now they could ignore people around them and push code out that wasn't the right code. And were they blocking other people by not answering questions? So a lot of these interesting kind of factors came up from this study. And that actually prompted a bunch of us to develop something that's called the SPACE framework. So the SPACE framework is a framework that basically says productivity is more complicated than you think. It's still more complicated than we think, by the way, we haven't figured that out. But with this framework, we were able to communicate that it isn't just about the number of pull requests or the number of lines of code, or the number of reviews that you do, that there are many other factors to productivity. So as I mentioned in my earlier work, satisfaction and well-being is a big dimension of productivity. Performance is another one. So are you delivering the right features? Are you delighting your end users in the code that you're writing? Do you have trust in what you're delivering? Is it secure? So many aspects to do with performance, harder to measure in many cases. Then the A in SPACE is for activity. So those are the things that we saw develop our companies using. So things like, believe it or not, lines of code used to be used as a productivity measure. Today, we're seeing number of tokens used, believe it or not. Maybe we'll talk about that a bit later on. And so those are the metrics there. There's still important signals maybe to look at, but you need to look at that in combination with the other dimensions. And then C is communication and collaboration. So how effectively are developers, say, on your team or in your organization, collaborating and communicating and coordinating with others? Software development of large systems is a team sport, right? So, looking at that is critically important. And then the last one had to related to efficiency and flow. How efficiently am I able to do my work? Do I get in this flow, this sense of flow when I'm working? I thought I'd just put one slide up about flow because not all of you may be familiar with that term, although I find lately it's become quite popular and people do understand it. So flow is having that balance between challenge and your skill level. So if you're maybe playing squash, for example, May and I used to play squash together, you get in the flow of the game when your skill matches the challenge. By the way, May always beat me in squash, but so sometimes, the challenge was a bit more than my skill, but we always had fun. And when you're in this flow state, you have this intense concentration. So some of you, when you're developing, maybe playing music, you can have this doing art, maybe even doing the dishes. Some people talk about getting in flow, doing housework. Joe's like, really? No, I'm not with you, Joe. But some people enjoy that and they get that sense of flow and control. A sense of control over your actions is also really important. And we have that distorted temporal experience. So anybody ever find themselves at 2, 3 a.m. still coding? I know I have, and you completely lost sense of time because you're really in the flow. And then in team flow, you can also experience it as part of a team. And so that enhances your creativity, your joy, your motivation, and social connection as well. And so looking at space, so anybody here heard of the space framework? It's not that well known in academia, perhaps compared to industry. See, nobody knows about it in this room. But out in industry, everybody kind of latched on to this framework. It took off. It went viral. And companies were like, oh, yay, we just need to, pick 3 of these metrics. Pick 3 metrics according to these dimensions, and we can measure productivity. And this was a lot better than before, where companies were just using activity measures. So it really took off because companies were struggling to try to understand, if we bring in new tools, what happens to our productivity. And DX, a company that I worked with that was recently acquired by Atlassian, they did a study of which metrics were being used across the industry. And what they found is that lots of activity metrics were being used. Efficiency metrics were also being used more in the line of how quickly are we shipping our code, rather than flow, the experience of the developer. And you see that satisfaction wasn't used much, a bit on performance, but very little on collaboration, even though this was very important. So I feel like this was a concern, and I saw this a number of years ago. So looking, and some other work, I mentioned DX, some other work that I did with the DX company was really drilling into this aspect of the developer satisfaction or their experience while they're developing. And we did, myself and Michaela Grayler and Abby Noda, we did a very big study, an interview study with dozens of developers across the industry, across the globe, in different size companies. And we found a number of factors really influence their developer experience. Many contextual characteristics do as well. And we also identified, I'm not going to go into these in this talk, but we also identified a lot of barriers to improvement, strategies they use to improve their experience, and coping mechanisms. So one of the coping mechanisms that some developers were using at that time was to go home and write code that they felt that gave them joy. So they would contribute to open source projects and basically kind of check out at work. Others would just leave. That was one of their coping mechanisms. But in terms of the factors, again, we see collaboration and culture coming up as a really big factor that influences developer experience, as well as product manager, aspects of development and release, and being in flow, developer flow, and fulfillment. So again, some of the same kind of patterns come up, this importance of how the developer feels and their experience working with others. So what about in the age of AI? So in the last few years, I mean, none of us can, in research or anywhere, can ignore the impact that AI is having on developers. So I've been looking at how AI is impacting both individual developers and teams of developers. Of course, I'm not the only one looking at this. There's a lot of studies. I'm just going to mention a couple here, but there are dozens. If you want to know more about this, you can choose your favorite adventure and read the study and see the findings that you're going to get, because there's some disagreement coming out amongst the studies, because different settings, different ways of looking at this. So the GitHub study, this was one of the earliest studies. They actually used that space framework that I talked about. So they had questions in a survey with developers to try to understand what is the impact of using generative AI and large language models on developers. And in fact, they found that developers were reporting at this time being more in flow, having reduced effort, cognitive load from doing repetitive tasks, less mental effort, less time searching, faster completion. So they were doing a lot better with efficiency and flow. Their satisfaction had also gone up initially as well. They felt that, they could automate the more boring, tedious tasks and spend more time on satisfying work. And their perceived productivity had also jumped up as well using generative AI tools. But other studies gave a different story, and we're seeing this still today in the latest studies that are coming out. So the meter study kind of created a little bit of a ripple, because they found that even though developers were reporting that they felt more productive, when they looked at kind of the throughput of features from idea to actual delivery, they were noticing some slowdown. They were noticing some bottlenecks in trying to prompt, in waiting for responses, a lot of slowdowns in reviewing and fixing the AI generated code. And it was worse for those that were familiar with the code bases. So experts were being slowed down more than the novices. So the novices were being helped because they were unfamiliar with the code and maybe unfamiliar with the technologies, but those that were more familiar were slowed down. At around the same time, about a year ago, there was a lot of talk about how vibe coding, anybody heard the term vibe coding? It's out of fashion already, by the way. Came out just over a year ago. It was a thing for a few months, and now it's, agentic. Probably next year, something else. But vibe coding was the big buzzword, right, last year. And startups, many of the small companies that were starting up were saying, we're able to go super, super fast, vibe coding their apps and getting those out there into the hands of their users. And around a quarter of those accepted even into the accelerator. So that was into the Y Combinator accelerator, used AI to write 95% of their code. So this was even a little while ago. Yeah?
Can you ask questions?
You can ask questions. Go for it. That's okay, right, Joe? Yeah.
What was the reason behind experts being slowed down? Because I feel that AI is helping everybody.
Yeah, so that study is, I think, about 18 months old. So at that time, prompting was more difficult. It wasn't as agentic back then. Reviewing the code was a bit buggier. But even today, there are still some slowdowns happening, which I'll talk about, even with agentic. Yeah, we'll get there, but good question. Yeah, so in that study, it was friction from reviewing the code, fixing the code, knowing how to prompt, and so on. And now you're right. If that study was repeated in that setting today, we would probably not see that kind of slowdown, but we might see other problems that I'm going to touch on in a bit. Yeah.
And with the question online is, what definition of vibe coding are you using? Is there any code review involved, or is this
really good question? I have a paper with some colleagues called Good Vibrations. They can look it up, where we show the definitions by a bunch of developers. There's no one definition, but generally speaking, it's feeling like you're in that vibe and you're generating code. And generally speaking, you're not reviewing it. You're not trusting it. Yeah, but it's a term that was, I think, Andrei Karpathy suggested that term, and defining it. People define it in different ways. So some people do use the word vibe coding, and they do review. So Steve Yege and Jean Kim have a book called Vibe Coding, and they talk about also reviewing, at least at a high level, the code. So it depends. Good question. All right. So I'm a professor at the University of Victoria, as I mentioned, and I also teach. And one of the courses that I've been teaching since 2014 is a startup course. So maybe you have a course like that here to do entrepreneurship. Yeah, kind of.
Velocity, the accelerator.
Right. So you've got even something better here than we have. But I teach a startup course at the University of Victoria. And as I mentioned, for many years. And what I've noticed is that in the last couple of years, AI kind of came on the scene and showed this opportunity for students to go even faster. And the course that I've been teaching in the last couple of years has involved computer science students and business students. So students in the entrepreneurship program, and we bring those folks together. And what I noticed in some of the research that I've been doing in industry, looking at product managers, is that product manager role is also shifting a lot in how they adopt AI. So what we're seeing is that the PM or the product manager or the program manager's role, they are now able to vibe code, right? Prototypes. They are now able to code prototypes, right? That they can show their ideas. And the developer, who was before kind of over here doing all of the technical stuff, they can also use AI to do some of the product management work. So modeling, generating designs, modeling requirements. And so we see these two roles kind of starting to come together. And I'm sharing this because this is what I saw and encouraged to happen in my course between the computer scientists or the software engineers and the business students. So this is the course, we call it Startup Studio, and it brings these two groups of students together, as I mentioned, software engineering and entrepreneurship students. And they basically go through a cycle of different milestones. So after 3 weeks, the idea is that they have a very early MVP, minimal viable product, that they can put in the hands of the users and check, is this meeting the needs that they think? So the year before last, so this in 2024, I encouraged my students to use generative AI, contrary to other courses, perhaps. And they were very reluctant. They really were not using it. And about halfway through the course, I stood up and I biocoded, didn't know the term then, an MVP for one of the ideas that they had in the course. And I showed them with a few prompts how you could create this MVP. Even that didn't really change how much they were using AI. In 2025, I did the same thing, except now I did it in the first day. And I showed them how I could code with a few prompts, one of the projects from the year before, and do a better job than the students had done before. So these folks really did lean in this time in 2025, September 2025, to using generative AI technologies. Now you might wonder, but you're teaching in a university, shouldn't you be teaching them how to code, how to write code from scratch and all of these things? Yes, they should learn the fundamentals in the other courses, but in a startup course, if they're going to go out into the world and create a business, and some of our groups do, they need to be able to keep up. So before, your code was your asset, right? It was your edge. But now it's, and the idea, you could kind of share what you were doing. In fact, we even had them open source at the beginning because other companies couldn't catch up as quickly. But now with Vibe coding, you can just even copy and paste from the website the description of the tool, and you can generate an app, right? So we were telling them, you got to go fast, right? If you have a good idea, your competitors are going to take it and they're going to go faster than you. So going fast is really important. So they did. They went fast. And of course, I told them, software engineer, I told them, do test-driven development, write your requirements, do all of the things, review the code, don't just take the code. All right. So it was trying to be, use those fundamentals. And so what happened? Well, about 4 weeks in, so I surveyed them and I had them write a diary basically every week of what they were doing. And about 4 weeks in, everything was going really well. So one of them said, the UI looked exactly how I had imagined it. With a single prompt, there it was. There was the user interface for my app that I could give to the users, within a few weeks of having this idea. It gave us code that was clean and reusable, some of the students were saying. And it helped us progress a lot faster than we had before. They were going at the speed of light, in building this app. And as a business student, it taught me so much. So what was fantastic to see was that the business students were vibe coding, creating some parts of the app. And the computer science software engineering students were doing some of the work on the business side. So coming up with the canvas, the idea canvas, the business models, and so on. They were doing that on their side. So that was 4 weeks in. So everything was going really well. 8 weeks in, things were not going as well. So I heard, one student saying, I want to change this part of the app, but the software engineering students say it's too hard. We can't change that button, move the position of the button on the app. And I'm like, what? What's going on? Right? So I started, I looked through their logs and I heard things like, well, small changes were hard, right? So they got to the point where they couldn't make even small changes to their app. And some of them said, we just ended up scrapping it all, right? Which today is a good strategy, actually. We'll get to that later on. So they ended up scrapping it all and starting over. It would have been just quicker to just do it all myself, rather than trying to change it. And I spent a lot of time debugging, and I started to also see tension in the groups as well, because some people kind of understood what they were doing, and some people had no idea. And so what I thought, honestly, at first, is that I thought, technical debt, right? Do you folks know the term technical debt? Right. So I thought, they have technical debt, right? They have messy code, they have a poor architecture, it's not documented, right? And it's just technical debt. They can fix it and they can move forward. But it turned out that it wasn't just technical debt. It turned out that nobody on their team really understood what was going on in their app at all. So they had what I'm calling cognitive debt. I'll define that in a minute. And then when I asked them, well, why do you have that feature? They didn't know either. So despite that I had told them to do all the good software engineering practices they had been learning for 4 years, this course is in 4th year, they weren't writing down, right, what their requirements were. There wasn't a clear description. Team members didn't know what they were supposed to be even coding. And so I thought, well, I can fix this. Anybody here from the business side of the world? So business use a lot of canvases. They use, business model canvas and so on. And I thought, I need Canvas to keep up. I co-teach this course with a wonderful professor from entrepreneurship. I thought, I'm going to put together a Canvas and then have the students get together in their groups and talk about, well, where are you on your journey from a prototype to a product? So remember that in this course, the students are creating an early version of a product, and some of them stay on afterwards and create a company and actually build it out into a product. We have 3 teams doing that from last term, still working on their product. So where are you? Is this really something, build one and you should throw it away? Or is it going to be a product eventually, right? Because if it's a prototype, maybe you want to go back, right? And then, do you have technical debt? How much technical debt do you think you have? What kinds of technical debt do you have? And do you have, so I described to them this concept of cognitive debt. And do you have a lot of cognitive debt where people don't really have lost the plot? They don't know where they are. And if you do, what are you going to do about it? And then I asked them to talk about their short-term priorities. Where are they in their journey towards building a startup? And what is their plan going forward? Are they going to, keep going and hope it works till the end of the term so they can get their A in the course? Or are you going to keep it, but, make some improvements to it? Or are you going to throw it away and start afresh? And what, who, and why? So this actually helped a lot. It really helped the teams to kind of slow down, catch their breath, and realize where they were and come up with a plan for moving forward. And this is kind of like a picture of one of the teams, what they wrote on one of the canvases here. So you can see that they were really thinking thoughtfully about where they were and what they needed to do to address the technical debt and the cognitive debt and what their priorities were and what their plan is going forward. So you might think that, oh, well, this is just in a course, right? This is just, something that the students were doing. They weren't, slowing down. They weren't documenting. They weren't taking their time really understanding what they're doing. And I posted a blog post actually back in February about cognitive debt and this, erosion of the mental model across the team. And what I found is that cognitive debt is also being experienced in industry as well. So Simon Willison, very famous programmer, he said, this is exactly what's happening for me. I'm getting lost in my own projects. I'm losing the plot. I no longer have a firm mental model of what his projects can do and how they work. And this seemed to resonate with quite a few folks across the industry. So this made me kind of, really step back and think about technical debt and the relationship with cognitive debt. And also, I mentioned that my students not only had lost understanding of what they were doing, but they had failed to write down the important requirements, right, that they needed to keep track of. So I called this intent debt. And there are 3 different kinds of intent. And I'll get in and talk about these in a minute here in the rest of the talk. And the following slides are, I posted another blog post. And again, I heard from a lot of practitioners that these ideas really resonated with them. And so I'm sharing some of the things that they shared with me, some of their experiences, and some of the ways that they mitigated these as well. So technical debt, I saw lots of heads nodding when I mentioned technical debt, so I don't need to say a lot about this. It's been a familiar concept for quite a long time. Martin Fowler also has this quadrant that really kind of identifies, are you being reckless or prudent in your technical debt when you accumulate it, or are you being, deliberate in doing it or inadvertent? And depending on where you are, maybe you're being reckless, but you're being deliberate about it. We just don't have time for the design right now. We don't have time to do that. In startup, they would always have some technical debt. That was expected because they didn't even know if they were building the right thing. So build a prototype, get it into the hands of users, make sure that it's good fitness for purpose, and then if it is, then improve it. So they would, deliberately do it. And they chip now and then deal with the consequences. The reckless and inadvertent is kind of what I was seeing a little bit, like what's layering in your project. And the prudent but inadvertent, now we know how we should have done it, and they'll go back and change it again. So as I mentioned, sometimes technical debt is intentional. You're trading that quality for that speed. You're going to pay it back later on. Kent Beck talks about, though, how technical debt limits optionality. So when you have technical debt, it makes it harder to change the system. You have to do some re-architecting, some refactoring. But in general, technical debt is visible and you can measure it. There are tools for doing it. It's observable, and you can use a lot of different refactoring approaches to pay down the technical debt when you need to. Of course, do we? Not always. That's kind of a bit of a pipe dream sometimes. Sometimes we live with debt forever. But in principle, you can pay it down. And so when I think about technical debt, I mentioned that technical debt lives in the code. It is a property in your project of the code, of the architecture of the system.
Before you go,
Back when?
yeah. So, refactorable in principle.
Yes.
Previous guy, Solomon meant he lost control over his own project.
Yeah.
So that means he's not able to do
Exactly. Yeah. So the question is, here we say it's refactorable in principle. And my selection of in principle is a little bit related to that. In the previous slide, I had said that the students had lost control, right, of their project, and they weren't able to change it. Yeah. Thank you. That's a good lead into the next part of my talk. Sure.
So there's one question which says, security and correctness are not always first-class citizens in startup code. Right? Is this a problem you've seen tackled well with these technologies, these new technologies, or is it kind of more hurting?
Security has been a headline for quite a few years. Being a risk, it's still a risk, but there are folks that argue now we can have particular agents that we train to watch out for these security problems. So we're still on this journey, right? We're not there, we'll never be there because things will keep changing, but we're still learning, right, to use these new modes, right, of writing code. And so security is a big problem. That's okay. Let me just slow down a little bit here. This is why, how many people here are taking software engineering and computer science as students? Don't leave. We need you. Okay. Because yes, you could maybe have an agent, that you could deploy, right? To, you could create a harness around it and say, here are all of the vulnerabilities you need to be watching for, and to have an agent do that for you. But you can only do that if you know about it, right? So that's why we need engineers. So engineers and software engineers or computer scientists stay, because you need to understand the fundamentals, right, to use these technologies. And the same for correctness as well. So in the startup, honestly, we don't worry so much about it. until they start taking people's credit card, and then we worry about it. But at first, in the first few weeks, we just want to know, is this something you would use? Is it something you would pay for? And then we worry about security a bit later on. But yeah, a lot of risky stuff happening because of that.
Another question is connecting it to a previous data point where you said newer engineers found that they were more productive and senior engineers found that they were getting slowed down. How do you reconcile that with the 4-week, 8-week mark in your startup class? Where is this impacting newer engineers as well? That they were saying that in the beginning, and then like 6 months later, they find that they're actually slowed down as well.
Yeah, really great question. Again, it comes back to knowing engineering fundamentals and principles. I was surprised at my software engineering students, honestly, that they weren't, but it was a new tool, right? It was a new power, right, in many of their hands, and they were just going fast without thinking about this. In terms of the experience of engineers, maybe I'll just do a little segue and come back to my talk. One of the things that I've heard from folks in industry is that in terms of expertise, the companies are very happy to see new developers coming in. So I know there's layoffs happening and a lot of distress, out there because of this. But I have talked to some executives of some very big companies, and they love the new folks coming in. They love the juniors coming in because they're more AI native. They have the engineering fundamentals, right, and the computer science fundamentals from their degree, but they're also used to using AI, and they're able to go a lot faster. It's more the middle level that are more at risk, I think, because they're resisting. Many of them are resisting using it. They don't know how to use it as effectively. And then the seniors seem to be doing okay because they have all of that experience and domain knowledge and so on. So there's kind of interesting things happening and shifting, right as we're watching it. Yeah. I'll go back to my talk. Are you still with me? Okay. All right, so we've talked a little bit about, so you'll remember I'm talking about this triple debt model, and I've talked about technical debt. Now I'm going to answer Dan's question here about cognitive debt. Sorry, let me just finish up on technical debt. So in terms of technical debt and the impact of AI, I would say the jury is still out. So I've heard from different practitioners that believe that, AI, quality in the code, AI is going to fix that. There's going to be an agent, right, that's going to look for code smells and it's going to just refactor the code, or heck, just re-implement the whole thing from scratch, right, using a good design, right? But there are others that, are worried about this, that are worried about the quality, particularly with legacy software. So Joe and I go back a long way. For legacy systems, you can't just throw them away. There's a lot of business logic buried in these systems that people don't even understand. Right? And so in the legacy systems, AI and agents, yes, they're helping to make some improvements, but there's still some struggle going on there again. There are even some people that say that code, as we know it today, so JavaScript, Python, whatever, is going to disappear completely and is going to be in a level down, right? And it may be hidden infrastructure that is managed by our agents, and we'll be, operating at this higher level of programming language, potentially, of a formal language. And code is perhaps, this what Fred Brooks calls accidental complexity. A lot of, the challenges that we face with coding is really about accidental complexity, and essential complexity is more at the level of understanding the requirements and coming up with a design to meet those requirements and verify it. But as I said, there's a deeper risk, I think, that AI is accelerating the speed at what we're going, and it may be multiplying other risks that we're not even really paying attention to yet. So this is where I want to pivot to talking about cognitive debt, which was the term that I coined in my course last October, to realize that, technical debt is something that lives in the code, but this cognitive debt is something that lives in people, in the minds of the people across the team. And before I get into talking about cognitive debt, how many people here have seen or read Peter Nauer's paper from, I think it was 1984 or 6, where he talks about software as a theory? If you haven't, you should read it. I make all my students read it. And so Peter Nauer, 85, he says that a program isn't just code, okay? A program is really a theory of what the system is supposed to do. And this theory resides in the minds of the developers and the engineers and the designers and maybe some key stakeholders as well about what the system is supposed to do. And this theory has three different aspects to it. So one of them is this world to program mapping. So there are some maybe business logic or some engineering goals that we're trying to implement from the real world, and we have to map those to the code. So the developers working on the system have this understanding of what it is that's supposed to be in the program and how that maps to the system, whether it's to the code or whether it's to components or the architecture. The second part of the theory is the justification of the design for the way that it is. So why certain structural decisions were made? Why this architecture and not another architecture? Why this database schema? Why this data model? Why these different integration points so that other systems can integrate with them? And why behind the different technological choices as well? And then the third part is the modification capacity. So we all know that as software, once it becomes useful, we're going to have to keep changing it, right? If people are using software, their needs are changing as the software changes. And so we're always going to have to be continually updating the software to meet those new needs. And so the modification capacity refers to, can the team reason about the safe change paths, right? Which is what you were chatting about. And that this is, it turns out, I'm hearing lately, maybe it'll change, next month it can be different, but lately I'm hearing that this is the biggest risk with AI generated code, is this ability to understand how it works and how I can make changes. So as I said, software isn't just about individuals, it's really about a team. So this notion of cognitive debt is not just about the minds of one developer, but it is about this understanding that is distributed across the team. And a little bit of a theory here that I like, distributed cognition theory by Ed Hutchins. He talks about how our cognition doesn't just happen in our minds, but it is distributed across our tools and across other people we work with and across the interactions that we have with those other people and the way that we interact with those tools. And so people, artifacts, and interactions are where our distributed cognition lives. And in software development, we see these across things like code reviews, retrospectives, and conversations that happen across developers. So when developers pivoted to working from home, what we found was these interactions were not happening as much, and they were starting to lose track of what they should be implementing and who was doing what. So understanding is distributed across all of these things, and today, of course, teams include both people and AI agents, right? So this distributed cognition isn't just in the minds of people, but it's also in the minds, let's not use the word mind for agent, in the memory, okay, the context of the agents. So cognitive debt is, this is the definition that I came up with. It's a project level property. I'll get to you in a second. That reflects the erosion of this shared understanding of the software across a software team over time. Okay, that's cognitive debt, project level. Okay, I don't use it to mean just a single person. It is across the team. Okay, and an important part is that there's gaps, not just in our shared mental models of the system, but we also start to lose track of who knows what in our team. This is called transactive memory, right? So I knew this morning that Jo knew where the university was, but she didn't know that I was sitting in the restaurant, not in the lobby, right? So we lost a little bit of transactive memory there in our communication about where we were going to meet. But knowing what we know is also called common ground. So cognitive debt isn't just about who knows what, but it's also who knows what. And it's really different from momentary cognitive load. Okay, so cognitive load is something that I've studied a lot in my prior work. That is more at the level of the individual, right? With AI, what I've been noticing is that cognitive debt is accumulating faster and faster. And I found this paper that talks about this notion of cognitive surrender. This is what my teams did. They surrendered their cognition to the AI and just had the agents, right, build their software for them, and lost cognition, lost hold of their cognition as a result. I'll take your question. Sorry, I just wanted to get through this one.
I was thinking about when you say that it is not in individual developers' mind, it is distributed among in the whole team, right?
Yeah.
But the way teams used to communicate in the classical way, you have flowcharts, UML diagram,
Yes.
you have ER diagrams, these sort of things. So do you think these are dead? Like, because
No.
you need to share the knowledge, right?
Oh yeah, great question. So, I mean, cognitive debt accumulates not just at the level of the team; it also accumulates in individuals too, right? And then it's that shared understanding that erodes. So, a UML diagram. Let's talk about that, for example. I don't know if you've ever joined a project late and been given a UML diagram, and it's kind of meaningless, right? Or even a wiki. Anybody join a project that had a wiki? And you're like, what the heck's going on in this thing? I can't follow it. I do not have a mental model. But if you're there from the beginning and you're talking to people and you played a role in building that model or building that wiki over time, it makes sense to you, right? And that's that interaction that Hutchins talks about. Our cognition was formed through our interaction and our kind of, exposure, right, to those things. Whether we created it or not, we were exposed to it. So great example. I'm going to use that in the future talk. The UML diagram plays a role in that. All right, so that's cognitive debt. So as I mentioned, I've been posting on LinkedIn, which is not something I did a lot of before. And I found it really interesting to kind of hear practitioners, I would say, are hungry for knowledge right now. They want to know like what they should do next, how to deal with, a bit of the crisis, right, that we're in right now across the industry. I would call it a crisis. It's a revolution, right, in how they're working. And they're looking for ways of addressing the challenges that they're facing. So any graduate students here? Some graduate students, yeah. Any undergrads thinking about grad school? Yeah, do it. Okay, we need more research. Okay, because they're trying to figure this stuff out. So Russ Miles has been writing these incredible essays. He's a philosopher, and he's been reading some of the stuff that I put out there and some of the stuff my students put out there, and writing these essays that are set in a cafe. There's a cat called Sophie, and there's a library in the cafe, and people come in and they start talking about these, what AI is, the impact that AI is having on the development. And there's a Dejine, which is, like a genie for the AI that also pops their head up every now and then and kind of joins the conversation. Really, really, if you like that kind of thing, really amazing essays. And he had a post on cognitive debt. This was based on my article, and he said, we tell ourselves lots of half-truths. And in this age of AI-assisted coding, we tell ourselves, we understand it well enough, right? It's good enough. We'll get back to this, right? And in software, we call this moving fast, right? This is kind of your question, I think. But in reality, we're borrowing against cognition, and eventually we pay interest in confusion. And that's what we're seeing, right? So yeah, have a look at some of his stuff if you're interested in that. So the other thing that I heard from a lot of practitioners are also ideas on how to diagnose and mitigate cognitive debt. So in terms of diagnosing cognitive debt, we can see it in those individual signals, right? So the individuals are struggling, right, to understand the code. And they have confusion about unexpected behavior. They make a change and, this other thing is doing weird stuff. It's like, why is that, right? And cognitive fatigue. We see cognitive fatigue trying to figure it out. Anybody here using AI a lot, feeling more exhausted than they did before? They were using AI. This is common. This is across the industry. People are burning out like crazy right now. AI fry, right? And so we see cognitive fatigue because it's more tiring to try to figure out something that somebody else did than just sometimes doing it yourself, right? And there's reluctance to modify code written by the AI. So this is a signal there's cognitive debt. And this was kind of the first clue that I saw in my teams when they were like, no, we can't make that change. I'm like, what do you mean you can't make that change? It's a simple change. And they're like, no, we can't make that change. Everything will break, right? So that's another signal. And then team signals, people start asking each other really basic questions. And there's slow onboarding, onboarding of agents as well as people. That could also be a signal. And there's a low bust factor. So there's only one person that really knows how the thing works, right? And if they leave or are ill, nobody can really make the change. And poor awareness of who knows what across the team. And I'm just plugging my students' work, the developer's cognitive experience of overcoming confusion. She talks a lot about this kind of confusion and ways of overcoming it. And then there are different ways of preventing and mitigating cognitive debt. So this is not a bad story. This is just a bit of a sad story, I should say. This is just a wake-up call that not only do we need to pay attention to technical debt, but we also need to pay attention to cognitive debt. What time did I start? Was it 9? 10. So I'm okay to go over, I guess, because I've been taking questions. So one way that we can prevent and mitigate cognitive debt is we can design for troubleshooting. So troubleshooting is not the exception when we're coding. Okay, troubleshooting is not the same as debugging. Debugging is, at the level of the code. Troubleshooting is kind of at the level of your understanding or trying to, figure out what's going on. And we can design for troubleshooting by ensuring that we have diagnostic legibility in our system. So we have some way, we have some agents maybe that help explain to us what's going on and give us insights on what happens if we don't understand the code. And then we can do things like system walkthroughs. So the model these days is to do code review, right? So I write some code, create a pull request, and somebody else reviews it independently. Maybe they understand the code doing so, or maybe they just skim over it and go, tick, it's done, right? That isn't going to work so well with AI-generated code. There has to be more deeper engagement and understanding of what's going on, unless you're just really not paying attention to the code. But even then, you need to review at the architecture level what's happening. So system walkthroughs with the purpose of not so much, evaluating the design, although that's a good idea, but system walkthroughs to build understanding across the team so that people on the team understand what the architecture is like, what the different components are doing, how they're related, what the dependencies are, and what the different abstractions are. Postmortems and retrospectives. So retrospectives are used a lot in industry. I've observed quite a few of them, done some research on them. They tend not to be used as effectively as they could be, but a retrospective could be done for really kind of taking that step back, maybe doing a walkthrough, maybe doing a postmortem when something went wrong. Maybe there was a security issue. How did that happen? How do we fix it? How do we make sure we don't have something similar in the future? And then Russ Miles, who I mentioned, that philosopher that writes essays he has a book as well. He gives incredible talks, and he's been proposing this idea of habitat thinking, which goes back to Richard Gabriel's ideas of habitat thinking from decades ago, and Chris Alexander's design patterns. So thinking about where it is that developers, engineers, end users, and agents maybe come together to design the software. And thinking of it as a habitat rather than thinking about it, I'm going to build these different tools and give them to developers, thinking about the whole design of the environment that supports that shared understanding and that shared cognition across the team. A little bit of a different, he has actually a GitHub project for doing this. Yeah?
What I'm seeing is you're saying just keep doing the things we know work already.
Absolutely. Except now we really have to do that.
We did before.
We knew we had to, but we didn't do them as much as we should have. So the fundamentals, I think that this is a good ending maybe to my talk, or a good takeaway from this talk is that we need students learning those fundamentals and really putting them into practice. So really thinking about how we elicit requirements, how we document them, right? How we model them, and then how we verify the code. What we've lost in particular is more the writing of the code part, right? Which was always actually quite small anyway, right? It wasn't a major part. It was never really about the code. So should we measure cognitive debt? So I mentioned I'm hearing from practitioners, and I've heard a lot of different things. Some people are, I would say these can be sometimes controversial, that we should measure them. Not everything has to be sort of a number. But it's interesting to think about that. So Leonid Sokolowski has been chatting with me. He actually wrote to me yesterday. He now has a product that he's about to release, and he wanted me to look at it. That gives a way of coming up with this feature comprehension score. And he uses NAUR's 3 levels of understanding to come up with that score. So, how well is the team doing at world to program mapping? So there's a little quiz that kind of questions that. How well, can they justify design choices? And how well are they able to understand modifications that can be made? What is their capacity for modifications? And he comes up with this. These are scored at a team level. So he has this quiz that's done in a retrospective. And at the end, you have a team level score that comes out in your retros. I'm really excited to look at his product. I haven't done that yet. Somebody else, Adam Sursor, talked about a cognitive debt score. 5 questions to ask in a retro. Explain modules without looking at code. Can you debug at 2 a.m. without AI? Of course you can't. Do you know why this implementation and not some other one? And does it take a long time to onboard someone or some agent that's new? And is code maintainable if AI goes away? And he says yes. If you have cognitive debt, if you answer 3 or can't answer 3 or more than 3 out of 5 of these. So I do want to say though, I've been working on space and DevX and now this, and metrics have a place, but we need to be careful with metrics, right? Anytime we measure a metric, anytime we measure something, we bring attention to that, and we may ignore something else that's just as important. Yeah.
Earlier, you talked about intent debt.
We're getting to it in a minute. Yeah.
Thank you.
Next. Okay. Intent debt. Q. Yes. I'm excited to talk about this one because I think that this is the one that is the biggest risk, because I do see that there are good ways that we can manage cognitive debt. Once we know about it and once we get people to slow down and take their time on this, we can address it. Intent debt is a little bit trickier. So technical debt lives in the code, cognitive debt lives in people, intent debt, a little bit opposite, lives in the absence of artifacts. Okay, so we have intent debt when we don't have a good description of what our intent is. So here's my definition for intent debt. The absence or erosion of externalized rationale, goals, and constraints that guide how humans and AI agents evolve the system. It lives in the artifacts, or more often in the absence of them. So that's what I mean by intent debt. And I'm hearing again from folks in industry that they are recognizing this problem with intent debt. And of course, things are moving at lightning speed. I'm also seeing solutions being proposed for this as well. So that's kind of cool. But AI, as we know, it's a loudspeaker, it's an amplifier, right? If you have a team that has strong software engineering or intent practices, we're finding that AI amplifies that clarity that the team has. If a team has weak practices, then we find that AI fills the gaps with hallucinations and makes things up with plausible guesses. Right? So AI, we know this, right? If we don't give it good enough instructions, it will just fill in for us, right? And if it loses track after we've been, in a chat conversation for a while, it will make stuff up. We've all, I think, seen this by now. So diagnosing intent debt, we can see intent debt when changes don't line up and no one can explain why, and our users are just unhappy. Agents struggle. So we can see a lack of intent debt when they do not have good context for how they work, when you're taking a long time and using a lot of tokens. Because they're not sure, right, what they're supposed to be doing. It's not written down. And nothing is written down. And this is unfortunately what I saw with my teams, but I'm going to fix it in September. They had forgotten requirements and constraints. And intent depth, so somebody said to me, you don't need to write anything down. You can just discover it again from the code. Somebody very famous. I won't say who. Because, you know, he's very, very smart and he could be right. And I'm like, no, that you don't see in the code the decisions you made about the things that you're not going to implement, that world to program mapping. There are things that you decided not to do, and that is not in the code, right? So ways of mitigating intent debt. So the question at the back, you know, these are the things that we've known forever that we should be doing. So guess what? You know, these are all familiar to you, right? Decision and rationale records, ADRs. So architectural decision records capture what was decided and why, and domain-driven design, right, as well, capture intent and make it explicit before it is encoded. Having context artifacts. So hopefully in some of your courses, you're learning about context engineering and harness engineering, like those different keywords that are kind of related. Often geared more at the agents, I think, skills for the agents, playbooks and instructions for the agents. But this is information that we need to be human readable as well, right? The humans and the agents together need to use this information. And Birgitta Botmuller talks about having not just feedback, but feed forward, right, to your agents about what is your intent, about what it is that you're designing. And we need executable intent. So just having things written down that nobody actually has to make sure we're following is not enough. So we need BDD specifications and tests to verify not just that the code works okay, but to verify that purpose, right? That end user purpose, and to show if the system may drift from its intent. So intent debt can also accumulate when we deploy our software to our users and they're using it. And we know that when we get new software, we change, right? Our expectations change for how we're going to use it. Oh, we really wanted to integrate with our calendar, right? Or I really want a notification to come 10 minutes before my meeting, not a minute before my meeting, right? So our requirements change. So intent draft drifts when we just go along super, super fast, implementing our features and not paying attention to the users and how when they adopt the software, their needs change. This is something that worries me a little bit about A/B testing that's done at some large organizations. They'll try a feature, they'll try 2 versions of it, and they'll pick the one that kind of induces the behavior of maybe clicking or staying on the site a bit longer than another version. But that isn't really getting at what users truly want. To really understand users, we have to watch them and talk to them. This return to the fundamentals has been a theme, I think, throughout what I've been sharing. And any of you that have seen me give talks before know I always have a slide to Marshall McLuhan, who is a Canadian. He died in the 80s. He was a technologist, also a philosopher as well. And he studied media. And by media, he means a new technology. And he has these 4 laws that anytime we have a new disruptive technology that comes along, it enhances something, it makes obsolete a prior technology, and it retrieves something that we used to do before, but we stopped doing when another technology came along and retrieved it. And when we overuse it, it reverses the very thing, right, that we were trying to improve through the new technology. So think cars. We created cars to enhance our speed, but when we have too many cars on the road, it slows us down. That's also a technology. So this retrieval one, though, this retrieval of the fundamentals is pretty interesting. And Alistair Coburn on LinkedIn saw this in my article, and he's like, "Wow, I've seen this several times in my career. I didn't know it had a name." So he was trying to name this retrieval of why is it we have this thing, everybody stopped doing it, and then we have a new technology and we need to go back. Right, so this is normal. McLuhan shows us that this is normal, and we can learn a lot from what we used before. Sorry, a little bit of a tangent there, but I wanted to get that in. So together, this triple debt, I call it a triple debt model, which is pretty brave to say that there are only three, because there are actually, I don't know, dozens of types of debt. There's social debt, there's comprehension debt, there's security debt, comprehension, I mentioned already, lots of architecture debt, lots of different kinds of debt. But I'm focusing on these three at the level of software health, and I'm almost finished. Yeah, last couple of slides. So there are three layers to the software system. The technical debt that I've talked about, it lives in the code, it's observable, it's measurable, it's refactorable, and its focus, oh, sorry, I should have changed that slide. Its focus of the technical debt conference I was at a couple of weeks ago. Cognitive debt, on the other hand, lives in people. It's the erosion of the shared understanding that they have. And intent debt is the absence of artifacts that capture the intent. And AI tools are actually pretty good at technical debt. And we're starting to see now some, just even in the last few weeks, I'm seeing tools released. They're talking about cognitive and intent debt as they release them. Somebody said they took my paper and they put it into Claude, and Claude created an agent. and the agent now helps them manage their cognitive debt and intent debt and their team, and they're loving it. Very, very cool. But what I wanted to say is these three debts are not independent. They really interact with each other, right? So, if you have messy code or a messy architecture, it's harder for people to build cognition, right, or understanding of the system. If we don't have good understanding, then people aren't going to write down what it is that they're trying to do. So cognitive debt can lead to intent debt. And intent debt can lead to technical debt. If you're not even sure what it is that you're trying to do about, and have possible changes, then you're going to end up with technical debt as well as a consequence. This is my AI generated picture for the talk, because there has to be one. But I kind of like it because it has like these arrows, right, that they show that they are all related and they reinforce each other. So we can't just ignore one. We have to, and we're going to likely have to live with some for economic reasons, right? We have to accrue some technical, cognitive, and probably intent debt so that we can ship quickly. But at least having awareness of it and managing it is critical. Let me skip this one. Lots of debates still going on across the industry about, should we write things down? Do we need to? Maybe we can just have an agent, share, teach people who are onboarding how the code works. I'm pushing back against that one. I think understanding should be a deliverable across the team, not just the code. Is all debt bad? How much do we need? These are still open questions that industry are still looking at. I'll close on what I'm going to do with my startup studio in September, and I'd love your feedback on this as well. Obviously, I'm going to now really enforce that they do use engineering fundamentals. I'm going to make sure that understanding is a deliverable across the team, and I'm going to make sure that they make intent explicit much, much earlier and continue to update it. So I mentioned putting my paper into Claude and generating, an agent to help you manage that. So I showed you that canvas at the beginning. I'm not sure this still works. Let me know if the QR code still works. I see somebody with the phone. But I put in my talk and the paper that I wrote on triple debt, and I asked Claude, single prompt, to create an app for me to use in my course when I teach it in September. And look at what it generated. It's pretty darn cool. There are little sliders for the amount of debt that they have, what kind of debt. There's little buttons they can click on to say what kind of debt that they have. And then in the next part, it says who's going to do what, and what are you going to do in the next sprint? How are you going to rebuild your shared understanding? What are you doing to capture intent? And how are you going to repay technical debt? So one prompt to do this, kind of scary. Anyway, I'll work on this and use something like this in September and see how it goes. Yeah, and then just closing on this part, there's lots of next steps. How do we reason about these? How do we balance? Are there other types of debt that maybe I should have considered? And how do we ensure a system is a good habitat? And with that, I'm going to close it up and happy to take more questions. Thank you. Can finish that. Maybe I had all the questions already, but I'm happy to take more. There's one over there.
Thank you. Clearly, I'm inspired by this talk. One thing about the idea of intent debt is it's not isolated to software engineering or engineering in general. Any technical things have this problem, and we see it over and over again. I mean, if you listen to blogs like I can't remember the name of it, but one of the examples was a canal system in Britain that had facilities built in it 100, 200 years ago for being able to drain it. And the people who were cleaning the canal didn't know that, and they pulled the plugs. So, and that the intent debt was lost because there were no artifacts anymore. They've been burned. The problem of reacquiring the intent artifacts is a really general problem. Do you have any thoughts about how to create engineering that will recover these things, especially because obviously they didn't know they didn't have that. That's the problem when you don't have artifacts, you don't know you don't have it.
Yeah, really, really great example. I'll just tell a little funny story about that. So my husband's renovating our bathroom right now, and we had a problem with the contractor. The contractor got frustrated with us, and I found myself saying to him, "The problem is we have intent debt." So I definitely see it kind of applying. Like we've made decisions, but we haven't written them down, and we've forgotten, right? There are actually not quite a few. There are a few people I see trying to build solutions for addressing intent debt or capturing intent. This is particularly important with agents, right? With now that we have agents into the picture, we kind of have to write this stuff down because the agents can go rogue, right? And they will fill in, at least today. I mean, you can have another agent to make sure they don't, but at least today, they will make up things, right? And this will get worse over time. And I do think as we go into the future, there could be a world where there are no humans involved with the software system. I don't think we're quite there yet. Maybe May thinks we are. No. Okay, good. I think humans still need to be part of that picture and still in control and accountable for what's happening. And I think, moving from focusing on the programming language, of where we kind of encode, and that's what we did really before, right? The intent was encoded in the code, in the development language, and now we have to have it at a higher level. And whether that's, using something like SpecKit, which Google just came out with, specifying specification. There are a bunch of companies that are trying to kind of use different ways of articulating your specification. To me, they start to look more and more like formal models, right? Like they're sort of like, oh yeah, right, right? Modeling languages, but I think we have to do that, right? And you have to be able to maybe even execute models on them to make sure that they make sense, right? And then surface them when they're needed. So again, it's kind of going back to what we had before. But maybe we have new ways of doing things now that can make it easier for us mere mortals, right, to keep track, right, of all the things that we need to keep track of. So I think there's more hope as well, right, in using some of the techniques that were suggested decades ago that were hard for humans, right, to kind of manage. But now we can do that with the help of agents. So I think things are going to get better, not worse, in that regard. Well, things are going to break first, and things will get better.
Can you go to slide 4?
4.
Number 4.
Number 4. Okay. Okay. I
remember the slide it was.
Yeah. You know what? I always tell my students to know how to do this, and I don't remember how to. There's a quick command. Nobody's asked me that for a very long time. Thank you.
Yeah.
This one.
Okay. The thing is, all these studies that were perceived.
Yes.
Nobody was measuring.
Not quite true. The studies I've talked about have measured perceived productivity. There are some other studies that claim they take a more objective view of productivity, but they are still constructs and they are still subject, they are still poor representations of true productivity. So,
Okay.
yeah.
What was the correlation between perceived and actual?
How do you define productivity?
Okay.
This is right. So, productivity is one of these human level terms, right? That is still not well defined. We throw it around. I did a study actually, it's one of my favorite papers of all time that I was involved in. I did a study with developers and managers, and I asked them how they define productivity and how they define quality, and how they each thought the other defined productivity and quality. And it was all over the place. People define these terms. Some people define productivity the same way they define quality. Developers didn't know how managers thought about it. Managers had a good sense how developers thought about it, but it was, it was not the same thing. And the reason I did this study was because I was sitting in team meetings at some large companies, and I would hear somebody say, "We need to do this because we'll improve quality and productivity." And I remember, and everybody's like, "Yeah, we need to do this." And I'm like, nobody knows what you mean by those terms. Like, nobody actually defines what they mean by quality or productivity. So good question. Yeah.
I'll let. Thank for the talk. This is amazing. So there's a lot of best practices in software engineering, was assuming software is an evolving piece, needs maintenance. But with the advance of AI, do you think software more and more can become more disposable? And if that's the case, maybe some of the devs are not. It's not mattering anymore.
Yeah, that's a really good question. So Kent Beck, I asked him for feedback on cognitive debt, and he said, it doesn't matter. We don't understand the code. We'll just re-implement it. Others are like, not quite that easy, right? For larger systems. I do foresee a world, and it's in the future, where the code is kind of more hidden from us. But now we're just operating at a higher level of abstraction. We still need to have that, some way of articulating our requirements, the end user goals, right? The requirements or the specification, right? For how the system's going to work, the requirements and then the specification. And then we need some way of verifying, right? That we meet. And so I do see us operating more at that level rather than at the code level. So I do see the code kind of disappearing, getting pushed down. But now we're moving at this level. And it is engineering, right? Talking about the canals, right? That was an engineering thing, right? Bridges, right? Code is more like the building blocks, right? That you use for building these things than the actual engineering of them. That could be wrong. Maybe we'll have agents running the world and they'll just watch us and they'll watch what we do and they'll go away and they'll make software and maybe we'll be happier, maybe we won't, maybe it doesn't matter. I don't know. There could be such a world. There are some people that believe that world is also going to happen. So, yes. Yeah.
So like you mentioned, AI tools, a lot of people who doesn't have that fundamental training in software development are starting to implement things. For example, like you mentioned in your class, business students start to build prototypes and stuff.
Yeah.
So how do you see that we can help these group of people who doesn't have this background knowledge to kind of build tools and also bridge those like intent depth and like cognitive depth, like how to help those group of people?
Awesome question. I think that I do see to a certain extent that we're seeing a democratization, of software engineering. I do want to be able, in my course in particular, to empower the business students to engineer and to learn, and they can use the agents, right, to teach them some of those engineering principles and fundamentals. I engage. Even before this last year, I engaged my software or the entrepreneurial students to write test cases, right? Because that helps them understand the requirements a little bit more and it allows them to dip in. So I think that we do see more of a democratization, right, happening of engineering. But if you're going to build something that's going to fly an airplane or deal with your, banking information, I still think we need people who study engineering and understand deeply system level thinking and of socio-technical systems. We still need that training. But, can my business student create a prototype for, keeping track of notes, of a holiday? Yes, they can do that. If you lose that, people's lives may not get lost. Maybe you lose photos or something, but they can do that. And then if they're going to actually try to make money out of it, then you need to engineer. Make sure you have engineers involved. But yeah, why not? Bring more over. We need more. Like everybody's like not wanting to take engineering and computer science right now. And I'm like, we've got it backwards. Like we need more, not less. We're going to have more software, more complicated systems, and we need more people over here.
I wanted to emphasize the point that you just made. I think there are lots of very different types of software. And a lot of the talk focused on startup software, which is a lot looser. And, there was a question about correctness. Well, correctness doesn't even exist in startup software. But business software, enterprise software, and then going into safety critical software, medical devices, et cetera. I think you're going to see either a lot less AI generated code or a lot more of the software engineering activities that ensure the correctness and robustness and other properties that you care about the software. But the question that I really wanted to ask, so please, so there again, please don't leave the field, because most of the software that exists out there is actually business software and enterprise software. It's not the casual software that you read about in the newspaper that is more amenable to the vibe coding. The business software is not amenable to the vibe coding. But what I wanted to ask about is the intent debt. That's requirements engineering.
Yes.
It's an open problem, and it's been a long problem. But I'm optimistic about that, because now there is more motivation to actually document requirements. I think in the past, there's always been motivation to document requirements, but the people who did that work didn't benefit from that work, right? They wrote the requirements and then someone else wrote the code. And so it was a little easier to be lax. But if you're writing the requirements for a prompt that you're going to give, then you actually benefit from being precise and being correct. And you can actually ask the AI, if there's an inconsistency, ask me about it. If there's, if you can find an omission, ask me about it. If you've got some ambiguity, ask me about it. Don't just go off and assume something and build it, which is what a developer would have done if the requirement. So I feel like there might be more hope in the intent debt.
Yeah, no, absolutely. And I think, that's why I'm saying, like, stay in this field so that you learn those techniques. I mean, you can create a skill, that also asks those questions, right? There's a gap, there's an inconsistency. Are you aware of that? So now you've got, a sparring buddy. I think Ahmed uses the question, uses the term, he thinks of AI as a sparring buddy, right? Like, now you have this sparring buddy to kind of make you think through your requirements, and it becomes more fun as well, right? More interactive. And I think in the old days, not the old days, like a year ago, a couple of years ago, people wrote requirements, not for themselves, as you said. They wrote it because they were told to, and they knew nobody read them, right? They knew nobody updated them, and now it's like, if you don't update them, your agent's gonna go do something, right? So it's kind of nice, but we're still I think we're still figuring out how to write them in such a way. There's different schools of thought about that, in such a way that they're amenable to both humans and agents, right? To kind of efficiently use them.
Excellent talk. I had a general concern to raise about technical debt. I think it is present for sure in software engineering, but also with AI in every field, whether it's like you're presenting a presentation on some research or on a project that you've been working on, or even a software engineering project. I feel like what, in my experience at least, and things I've seen in my teams, has been that if you are reliant on AI in this pursuit for speed and productivity, whether that's to deliver deliverables or meet certain deadlines or just do work faster, right? You do get a kind of distilled understanding of things, and that does show up in presentations or just general discussions. I feel like there's been a gradual decline of the kind of intellectual rigor or the depth of understanding that we have in regular activities, whether that's classes and stuff. And that kind of gets glazed over. I feel like it's just like, because it works and everyone thinks like, yeah, this makes sense. I feel like that's a debt of sorts that we're incurring in the pursuit of speed or shipping products faster or money, but it's something that's it exists and it's something to be highlighted.
100%. I think most of us here probably notice some of this ourselves. You know, I was talking to a colleague the other day and she was depressed and she said, I can just, you know, get Copilot to write my papers for me and review them and summarize them. What do I do now? Like, what am I doing now? And this is not true, I think, right? I think human intellect, right, is still very important. And I think we have to push back on that and to pause, to take our time and to think very, very deeply. And we have insights, right? Like I still pore over papers. I even print them out and read books, and I'll sit on my couch and I'll read them, and I get a level of understanding and insight from doing that no summary, you know, agent giving me a summary of the highlights will do. You can't automate our understanding and our critical thinking. Sure, you can help augment, you can amplify, but you can't automate that. And I think, you know, people are realizing that and, you know, kind of slowing down. Russ Miles' stuff is just like, because of your question, me to stuff. Like he thinks so deeply about this. He has one essay called the word lost its meaning or something. I can't quite remember it. And it's about code review. And it's about how somebody on a team said, you know, we should have all code should be reviewed by a human to make sure that it's meaningful, right? It should be done in a meaningful way. But then that word meaningful lost its meaning, right? And now humans just read the code and they go tick, but they don't understand it anymore. And that wasn't the point, right? It wasn't the point that a human looked at the code and did tick. It was the point that the humans paused and thought about it. Anyway, he writes these kind of essays that make you really slow down and think. So, and that comes back to that habitat, right? The habitat is that place that isn't just about going fast, but about that place where we can kind of deeply think and understand what we're doing. Thanks for the question. It's not an answer that I've given you. I'm just rambling, but anyway,
yeah. So, like recognizing these stats all come down to the people that's using them. Just from my experience, I have known like two kind of people. One of them, AI idealists, they believe in everything that agents generate, and then they do make documents and things.
Yeah.
But they don't actually code review for the AI. And then at some point, because the requirements and the documents and like they're so easy to generate, and then they become too long and tedious to read.
Yeah.
Which I'm on the other side, like I don't really trust AI. I still kind of read stuff. And then with the intention, I want to read the documents. But a week after, my own maintained doc had become thousands of pages. That's it.
Yeah.
And it's to a point that it's impossible to understand.
Yeah, I think we're, as a society, I mean, this is a society problem, right? I mean, we've all read news articles, even books that are AI generated, and right now we can kind of see it, right? It's just boring. There's a level of, you know, something, the passion is not there. In the future, maybe that's going to be different, you know, maybe they'll learn and do a better job. But you know, personally, I'd rather see a little signal, you know, AI was only used to improve the English, right? Not to generate the thoughts. Yeah, I mean, I think in your classes, we, as a teacher, I've even had students, I asked them to reflect on their AI use and they generated like their blog posts. And I'm like, I could so tell. Like, seriously, you know, like if you're going to do that, even try a bit harder to make it, you know. And I'm not talking M dashes, I'm just talking about boring, like predictable vanilla stuff. So yeah, I think we need to fight back a little bit against that. And it starts with us individually, right? What we do individually. Yeah. Excellent. Thank you for the question. Yeah. Thank you everybody for coming and staying.
Thank you for coming. This is yes again, and thank you sing.
Thank you so much.
Thank
you so much.
All right. So there is a meeting with the graduate students this afternoon at 4:00 in DC 1331. If you're interested. Otherwise.